Okay, so we've looked at univariate outliers and we've looked at normality across each of the cells for the time to respond to an emergency. What we're going to be doing now is looking at homogeneity of variance, so looking at the Levenes test, so asking the question, are each of the cells, are the variances in each of the cells roughly approximately equal? And also doing the between subjects Factorial ANOVA. So, if you haven't already done this, please take off the split file, which was for gender. So if you haven't already taken off the split file, if you go to data, so if you go to data and split file and just click analyze all cases, do not create groups. So what that's saying to SPSS is I don't want to split my file between males and females, I want to look at everybody now. Just press OK. Let's go back to our data set. Now to conduct the between subjects Factorial ANOVA and at the same time do the homogeneity of variance test, let's go to Analyze and go to General Linear Model, choose Univariate. Now the time to react to an emergency is our dependent variable. The two factors are number of people present and gender. So let's pull both of those into the fixed factors. Now you've got a bunch of options here in these little squares, or these highlighted options here. The first option we want to choose is the option Options. So click on Options. Now we're interested in the main effect for people, gender, and people by gender. So we want to display means for each of these. So let's pull all those over, and as soon as we pull these over, this becomes available, compare main effects. Let's tick that. And as soon as we tick that, then we have three options here. Please don't choose LSD none. In most cases we wouldn't choose that, and what that's saying is I'm not going to worry about family-wise error, so I'm not going to correct for family-wise error. So our option really is Bonferroni or Shadak. We'll choose Shadak for these purposes, just because that's slightly more powerful than the Bonferroni adjustment. So let's choose Shadak. Now under the display, we've got a number of options. Let's choose descriptive statistics. That'll give us things like the mean or central tendency or variation type figures, so standard deviation, variance, and so forth. We'll choose that. Let's choose estimates of effect size, observed power, and homogeneity test. So that tests, that's the Levenes test. And choose OK. Now, I could have chosen the post hoc there as an alternative, but it probably would have been slightly more powerful, but I haven't chosen this option here nor throughout pretty much the entire course, so I won't choose it here. I'll just keep it the same bland old routine. And what we're also interested in with any sort of main effects and interactions, we do want to graph it. It'll give us a bit more of an idea what's going on if we can see it visually. So let's click on plots. And people, well, that was coded as 3 levels, 0 people present, 5 other people present, and 15 other people present. Let's put that on the horizontal axis, and gender as separate lines, and click on Add, and then Continue. When we're ready, we can press OK, and that will generate the output.
You can see in the descriptive statistics the mean and the standard deviations for each level of the independent variables are provided. So you may want to examine these means and standard deviations just to have a little see at what's going on. So for example, it looks like the more people that are present, the longer it takes the individual to respond to an emergency. So with the descriptive statistics table, you get an initial sense of the main effects, if there are any, of each independent variable. So for example, if you have a look at the row for those that had 15 people present, regardless of gender, they had there was a longer time or longer total time to respond to the person in distress, 59.87 seconds, than when there was no other person present, which is 37.1 seconds. The Factorial ANOVA can be used to determine whether or not this apparent main effect of people is statistically significant or not. Similarly, the ANOVA can test the main effect of gender. That is, whether or not the difference between the female mean response times, which was 46.58 seconds, and the male mean response times, 49.67 seconds, is statistically significant or not. The descriptive statistics table can also be used to get an idea of the interaction between the two independent variables. That's whether the effects of one variable, for example, the number of people in the group or the number of people present, on response times are dependent on another variable, for example, gender. Now, the Levenes test tests the assumption of homogeneity of variance. Its null hypothesis are that its variances are equal. So it needs not, so it needs to be not significant at the 0.05 level if this assumption is to be met. So the Levenes test for equality of variances is not significant. You can see its sig value is 0.267, which is above 0.05, which means it's not significant. So the assumption of homogeneity of variance has not been violated. ANOVA is not sensitive, not particularly sensitive to violations of equal variances assumption when the samples themselves are moderate to large and approximately equal sized. So therefore, when designing your study, you should always try, if you can, to ensure that you get reasonably equal group sizes. Now, this is the most important part of the output, as it tests whether the independent variables had an effect or not. The tests of between subjects effects table reports the outcome of the ANOVA. This is also known as the ANOVA summary table, and it gives all the information used in the calculation of the F statistic. Now, the important thing to look at here are the significance values on the independent variables. So let's look at the people row. The people row indicates that there's a significant main effect for number of people. The sig value is 0.000, which is below our alpha level of 0.05. Hence, we have a main effect of people. Let's look at the gender row. So the gender row indicates that there's a non-significant main effect of gender. The sig value is 0.081, which is above 0.05. And then you've got the interaction effect. This is the people times gender row, and that indicates that there's a non-significant interaction effect. So the sig value is 0.497, which is above 0.05. Now you've got the partial eta squared that's also sitting there, and that's a measure of effect size, and this is similar to the R squared in correlation. And the observed power is the sensitivity of the test. And this is the probability of finding a significant difference if they exist. It indicates whether we have sufficient sample size to achieve significance for the effects specified by the size of the partial eta squared. Now, power should be at least 0.8. Now, in this case, we have sufficient power for the main effect of people. Now, this is not surprising, given that they were significant, but the power for the main effect of gender and the people by gender is quite low. And this goes with the fact that we have a small effect size, and therefore it's suggesting that we don't have enough power to find a small effect size, and hence the result is not significant. So I'd like you to see other readings, your text and so forth, around information on effect size and power. So what do we know? So if you remember, we're interested in looking at the main effects and the interaction effects. What we found in terms of main effects, we found the main effect for people was significant. The main effect for gender was not significant. And what have we found for the interaction effects? Well, we found that the two-way interaction effect between people and gender was not significant. So if you remember, the variable number of people had 3 levels. So we found a significant main effect for people. Now the question is, where does this difference exist? Does it exist between 0 and 5 people present? Does it exist between 0 and 15 people present? Or does it exist between 5 and 15 people present? The main effect for people doesn't tell us where that difference exists. It just tells us there's a significant difference somewhere. To look or to find where this difference exists in this main effect for people, we need to go to pairwise comparisons. Now, because there's a main effect of people with more than 2 levels, we need to request those post hoc analyses and pinpoint a number where the difference in the means exists. And with a satisfactory Levenes test, which we found previously, the easiest way to do this is to request the main effect comparisons as I did previously when doing my point and click in SPSS. So the Shadak test is the preferred option, as it's slightly more powerful version than the Bonferroni test, which is the most general of the tests available for analytical comparisons. So there are a number of options that we may need to be aware of if the Levenes test is significant. Recall with a one-way ANOVA that because there are more than two groups, we need to do analytical comparisons when there's a significant effect in order to establish which groups differ from which. The same applies in a factorial ANOVA. When there's a significant main effect that involves more than two levels, then we need to find out where the level is, which level is significantly different. Now the comparisons I use here are using Shadak, the Shadak adjustment to control for family-wise error across the three tests. Now participants' response times to a person in distress, as we can see, are significantly faster when there are 0 people present compared to when there are 5 people present. Participants' response times to a person in distress are significantly faster when there are 0 people present compared to when there are 15 people present. And participants' response times to a person in distress are significantly faster when there are 5 people present compared to when there are 15 people present. So note that we only focus on the main effects and their comparisons when there is no significant interaction. So please have a look at your readings for how to write up a between subjects factorial ANOVA.